Okay, this optimization problem says at what argument x is the maximum vertical distance between the curves f of x equals 2 cosine of x and g of x equals sine of 2x on that interval achieved. So there's a lot of trigonometry in this problem. All the answer choices are in terms of pi, so this can be done without a calculator. So I'll do it that way. And let's see what we come up with. So first I'm going to graph these because it's kind of helpful, I think, to look at to get a visual going. So I'm just going to make some axes. And I guess my scale will be that that's a 1, that's a 2. Let's make that -1, -2. So I'm going from negative pi over 2 to pi over 4. So why don't I call this negative pi over 2, negative pi over 4, 0, and then pi over 4 will be like here. So I'm going to graph 2 cosine of x first. I think I'm just going to plug in points. So when x is 0, that's 2 times cosine of 0, which is 2. When you plug in pi over 4, cosine of pi over 4 is 1 over root 2, which is about 0.7, times 2 is about 1.4, so it's like maybe here-ish. We'll go with that. Sine's an even function, so when you plug in negative pi over 4, you get the same thing. And when you plug in negative pi over 2, cosine of negative pi over 2 is 0. So I'm getting that graph. And what about sine of 2x? So that would be a sine graph with a period of pi, but you might just plug in points and get maybe just as good. If I plug in pi over 4, sine of 2 times pi over 4 is the sine of pi over 2, which is 1. When you plug in 0, the sine of 0 is 0. When you plug in negative pi over 4, the sine of 2 times negative pi over 4 is the sine of negative pi over 2, which is -1. And when you plug in negative pi over 2, you get the sine of 2 times negative pi over 2, which is the sine of negative pi, and that's 0. So here's my sine of 2x graph. I'll label them. So this is g of x, and this is f of x. Okay, and it says find the maximum vertical distance between these two functions on the interval negative pi over 2 to pi over 4. So, our vertical distance varies. Let's call this just kind of an arbitrary point and the one below it. We're looking for an expression or a function that gives us this distance. I'll call it d. So this point's on the curve, the top one, so its coordinates can be called x comma f of x, which is x comma 2 cosine of x. This one's right below it, so I can call it x comma sine of 2x. To find vertical distances in the plane, subtract y coordinates top minus bottom. Okay, so my model, therefore, is, let's write it down here. My model will be d of x is equal to 2 cosine of x minus sine of 2x. And of course, my domain is told to me, so I don't have to think about it. I'll just re-express it, right? It's negative pi over 2 to pi over 4. So I'm only looking in that window. We do our calculus. We take a derivative. The derivative of 2 cosine of x is negative 2 sine of x. And then the derivative of negative sine of 2x, so I'll just treat the negative as subtraction. The derivative of sine of 2x is cosine of 2x, and then by the chain rule times 2. I'm going to clean that up a little bit and write this as negative 2 sine of x minus 2 cosine of 2x. These trig functions are defined everywhere, so I don't need to consider critical points that are undefined. So we set the derivative equal to 0 to find critical points. All right, now at this point, you're probably wondering, how do you solve this trig equation? Because it's not like you have a sine of x. The arguments are different, right? X and 2x. Well, that's when you kind of recall, if you're going to do this by hand at this point, algebraically, you want to recall that cosine of 2x, this is a pre-calculus or trigonometry fact, can be replaced with 1 minus 2 sine squared. Okay, it's one of the many identities. So I'm going to use that here. So it becomes 0 equals negative 2 sine of x minus 2 times 1 minus 2 sine squared. And this will become a quadratic that can be dealt with. Negative 2 sine of x minus 2 plus 4 sine squared. Again, I'm just kind of cleaning everything up. 4 sine squared minus 2 sine of x minus 2 is equal to 0. Let's divide everything by 2, and then I think we'll be good to factor. Okay, so this should factor. I'm having faith in the answer choices that this will factor nice because the answer choices involved pi expressions, so this should work. Let's see, I need a 1, so that should factor to plus 1 minus 1. Yep. Okay, and so this tells us that sine of x can equal negative a half, and this tells us sine of x could equal 1. Now if sine of x equals, if sine of x is equal to 1, then x is equal to pi over 2. So pi over 2 is a critical point. That's not in our domain though, so I can ignore that. Right? We're only limited to up to pi over 4. Okay, so when does sine equal to negative a half on the interval negative pi over 2 to pi over 4? Well, sine's negative in quadrants, in the bottom two quadrants. And so this means x is negative pi over 6. And then if you rotate from negative pi over 6 or negative 30 all the way up, you're not going to hit a negative value before pi over 4 here. So that's our only critical point. Okay, so negative pi over 6 is our critical point. That looks like a potential right answer. But let's just show that we found, just to be good about our calculus hygiene here, negative pi over 2 to pi over 4. Okay, I found that negative pi over 6 is a critical point. We just want to show that we found a maximum. Okay, so our derivative, where's our derivative? I'm going to use this version here in orange of my derivative to just check. I'm going to use that version. Okay, so let's plug in a value between, well, I don't know. Let's plug in a value to the right of negative pi over 6. You could even plug in pi over 4. That wasn't a critical point, so I can use it. So d prime pi over 4, I'm going to write this out rather than doing it mentally, is negative 2 sine pi over 4 minus 2 cosine. So 2 times pi over 4 is pi over 2. Now this is 0. So this is gone. And then the sine of pi over 4 is positive times negative 2 would be negative. So this is negative. That's just all we care about. So now I know I've got a negative in here. So our function is decreasing in that interval. The distance is decreasing to the right of negative pi over 6. And negative pi over 4 is in between negative pi over 2 and negative pi over 6. So I'm going to try that. That's negative 2 sine of pi over sine of negative pi over 4 minus 2 cosine of, so that becomes negative pi over 2, right? Because 2 times negative pi over 4 is negative pi over 2. That's 0 again. So that's gone. And sine of negative pi over 4 is negative. So this is a negative. And I have another negative here. So that makes it positive. So it's positive. And that must mean I'm increasing. Okay, so I found a max. And so our coordinate is at x equals negative pi over 6, the argument, and that is letter C. And I'm done with this somewhat trig-heavy problem.